Welcome guys. Welcome guys. In this section we are going to learn about polar Welcome guys. In this section we are going to learn about polar coordinates. So before going to start our video, I am studying in Sri Venkateshwara College of Engineering, Bangalore, Department of Computer Science and Engineering. As you know all my name. So let's get into our video. So firstly, introduction to cylindrical polar coordinates. Cylindrical polar coordinates are the three-dimensional coordinate system that provides a natural way to describe the objects of phenomena with the rotational symmetry. This system offers more powerful alternative and the more familiar Cartesian coordinates, allowing for the infinite representation of the cylindrical and axial symmetric structures. So, defining the cylindrical polar coordinate systems are radical coordinate, angular coordinate, and vertical coordinate. So, radical coordinate is denoted by r. This distance from the original from the point measured from the perpendicular to the z-axis. So, angular coordinate is denoted by theta, the angle between the positive x-axis and the projection of the point into the xy plane. So, vertical coordinate is denoted by z, the highest of evolution point measured parallel to the z-axis. So relationship between Cartesian and the cylindrical polar coordinates. So the cylindrical polar coordinate system is closely related to the standard Cartesian coordinate system. Each point in the system can be uniquely mapped by the corresponding point in the cylindrical polar system and vice versa through the set of mathematical transformation. So cylindrical coordination describes in the point position using the radical distance from the z-axis. The angle around the z-axis and the height along the z-axis is provided in the alternative way to represent 3D space compared to the xy and z axis used in the Cartesian system. So advantages of cylindrical polar coordinates are naturally representation of cylindrical spheres, simplicity of calculations and improved visualization and efficiency of computational applications. So natural representations of cylindrical shapes are the cylindrical polar coordinate system is well suited and melding and analyzing the cylindrical objects. The geometries such as pipes, drums are circular motion. Simplicity of calculations are many calculations are involving in the circular or circular system such as areas, volumes and vector fields are more easily intuitive in the cylindrical polar coordinates. So improved visualization are the cylindrical coordinate system can be provide the more natural and intuitive visualizations of 3D structures and the phenomena, especially those with the rotational symmetry. So efficiency computational applications are cylindrical polar coordinates are often performed for the computational physics, engineering and mathematics due to their efficiency and suitable for solving problems with cylindrical system. So representing the points of cylindrical polar coordinates. In cylindrical polar coordinates, a point in 3D space is represented by the triple r, theta or z, where r is denoted r is nothing but the radical distance from the origin and theta is the angular position around the z-axis and z is the highest evolution along the z-axis. So this allows the easy visualizations and the representation of the points in the space in the rotational symmetry. So calculating the distance and the angles in the cylindrical polar coordinates. So distance formula, we use the formula d is equals to square root of r square minus r1 square into whole square plus z2 minus z1 whole square to calculate the distance between 2 points in the cylindrical polar coordinates. So angular calculation is the diameter with the angle between the two vectors by finding the argument of the ratio in the projects into the xy plane. So visualizing the velocities is a polar to the coordinates on a 3D graphic of visualization and the relative position and the angles between the points in the cylindrical shape. So transferring between the coordinate system, Cartesian to cylindrical, cylindrical to Cartesian, advantages and the considerations. To convert from Cartesian x, y, z to the cylindrical polar r, theta, z and coordinates using the formula r is equals to square root of x square plus y square sin theta equal to take y by x and z is equals to z. So cylindrical to Cartesian. To convert the cylindrical to polar Cartesian, so r, theta and z are the Cartesians of x, y, z coordinates using the formula x is equals to r cos theta, y is equals to r sin theta and z is equals to z. So these advantages of cylindrical polar coordinates are often different from the problems with rotational symmetry in the simplify with the mathematical expressions and calculations. So considerations. Being mindful of the coordination systems while using the functions, derivatives, and the integrals as the formulas will be the difference between Cartesian and cylindrical polar coordinates. So applications of cylindrical polar coordinates are electrical engineering, fluid dimension, and astronomers and astrophysical and materials and science. Cylindrical polar coordinates are widely used in the electrical engineering to the mode of analyzing into the behavior, electronic motors and generators and electromagnetic fields. So fluid dimensions, it is the fluid dimension cylindrical polar coordinates are useful for the modeling and studying the flow of fluids in the axometric systems such as pipe flow in the rotating machine. So astronomy and astrophysics, cylindrical polar coordinates are employed in the astronomy and astrophysics to describe the motion of the cylindrical bodies such as certificated planes and stars relative for the central representations of the point. So material science. So material science is cylindrical polar coordinates are used to the model of the atomic structures and the properties of the cylindrical materials such as carbon nanowires and nanowires. So limitations of the considerations. So singularities are firstly underfed by the behavior of origin r is equals to theta, and the spiral direction is the direction increasing to the r approaches theta, and discontinuous jump from the coordinates near r equal to theta. Well, polar coordinates offer advantages. They also have some limitations. Significantly occurs in the origin r equal to theta. When the coordinates become the indifferent additionals in their increased specificity, it destroys when the r approaches theta, and the discourse for the coordinates in the new point of the phase must be careful consideration of working and polar coordinates. So conclusions and the summary. In conclusion, the cylindrical polar coordinates system offers powerful alternative on the traditional Cartesian coordinates by representing the points in the terms of angle, height, and the system provides intuitive and efficient solution for many applications in science, engineering, and the mathematics. We have explored the key advantages of cylindrical polar coordinates such as in the natural fit and the cylindrical and asymmetric problems and the easy visualizing and manipulating of the curved surface in the transistors. This ability of transformation between the Cartesian and the cylindrical polar coordinates was also discussed, along from the same transmutation between the coordinate system. So thank you. If you like my video, please like, share and subscribe my channel. Thank you.